Okay. We go through by one the details of this teaching plan. If you have any question, you can ask. So basically, this is a 2-unit course. We have 14 weeks. 14 weeks, so we have 28 hours lecture. But not 28, sorry. It's only about 24 hours lecture only, because another 4 hours is for tests. I mean the preparation and also for tests. Okay, the lecture should be every Wednesday, stated here. 11 to 1, and the place is at DK8. So starting from next week, we will have physical class lah, face to face. We meet at DK8. So for this semester, EAS 458, the lecturers involve myself. I'm the coordinator of this course, Dr. Shahrudin Shah, and also Professor Dr. Badrul Hisham. So there are 3 lecturers, and myself will involve with you 4 weeks, and then 5 weeks each for Dr. Shah and also Prof. Bad. So total it should be 14 weeks. Okay, the next is a course outcome. This is what we are expecting you to achieve by end of this course. So the first one, able to explain the principles and methods of pre-stressing, identify stress limits at transfer and service, and estimating minimum cross-section of pre-stress beam. That's the first one. And then number 2, able to design a pre-stressed concrete beam in accordance to current code of practice. Number 3, able to produce tendon profile drawing and detailing in accordance to current code of practice. As you can see in this course outcome, I hope you realize that we only focus on pre-stress beam. Pre-stress beam. So in other words, our scope, if please don't compare this course with other university, especially UTM, University Technology Malaysia. They cover a lot. I think their credit hour is not 2, it's a 3. So in our case, USM, we only cover for beam only, and that particular beam is only rectangular. Rectangular cross section, no T section, no U section, only rectangular section. So that's what we're going to cover throughout this semester. And for each course outcome, there will be assessment, of course. For CO1, there will be exam, will be assessed in exam, assignment, and project. CO2 is about design. CO2 is about design, the main things of this particular course. So the assessment type will be exam, assignment, test, and also project. And the last one, CO3, more towards the detailing, and you produce a tendon profile. So for this particular CO3, the assessment is only in project. There is no assignment, there is no test for this particular CO3. Okay, and also not in exam for CO3, because it will take times if we ask you to produce tendon profile in final exam. So better we assess you in project. So basically, if you look at from this part, we can conclude that for this particular course, for this semester, there will be 50% coursework and 50% exam. Under this coursework, there will be 3 components. We will have tests. There are 2 numbers of tests. Each will give a 10%. So 10%, 10%. Summing up, we will get 20% for tests. Assignment, only 1, 10%. And the third component is project, 20%. So altogether 50%. 3 components. Ataupun, or in other words, we can say there are 4 components lah, because we have 2 tests. 2 tests. And examination 50%. Since this is 2 credit course, the exam will be 1 hour only. Similar to steel design, 1 hour only. But you've given a choice in this particular course. In other words, for the final exam, there will be 3 questions, but you need to answer only 2 questions. This is for pre-stress concrete. Okay. If you have any question, you can ask, ataupun or you can write in the chat box. Okay, basically, I will explain a bit the overall content of this particular course. There will be around 7 topics, 7 topics to be covered. The first one, of course, lah, the introduction. This is will be covered by myself. And then we have service ability limit state. Okay, this is quite different with the RC design. If you still recall what you have learned in RC design, in RC design you start with the ULS, ultimate limit state design. But in pre-stress, it will be the other way around. It should be start with the service ability limit state. Then after that, we calculate the, we design for the ultimate limit state design. Okay, so design of service ability limit state, the second topic. And then we have losses, the third topic, losses. And then after that, we have ultimate limit state design, focusing on the flexure, the fourth topic. And then we have deflection. Deflection is actually covered under, it should be parked under service ability. But then to teach, we separate that one. Deflection, one topic. This is the fifth topic. And the last 2 topic is shear and blocks. Okay, so basically there are 7 topics. 7 topics. So let's see in terms of this assessment. From topic 1 until topic 3, introduction, serviceability limit state design, and also losses will be covered by myself. So under this part, there is no test, but only assignment. I'm talking about the coursework assessment. Coursework assessment. We will have 1 assignment and one assignment, and of course there will be 1 question from this topic. If I'm not mistaken, nanti kita tengok balik. Service ability will covered under exam. Assignment, the other 2 topics. There are 3 topics covered by myself. Introduction, service ability limit state design, and also losses. So assignment will cover introduction and also pre-stress losses. Meanwhile, for the SLS design, only assess in final exam and also project lah. Project. Okay, and then the 4th and 5th topic, ultimate limit state and deflection. This one will be covered by Dr. Shah. So under Dr. Shah, there will be 1 test here, 1 test. And the test will cover topic number 5, which is deflection. The test, topic deflection. So another topic, which is ULS, ultimate limit state. That one will be assessed in your final exam and also in project. Project. And the last 2 topic, shear and also end blocks. This one will be covered by Prof. Bhat. And under Prof. Bhat, there will be another test, which is should assess shear in pre-stress concrete. And blocks only covered in exam, and of course lah dalam in project. So basically this is the perancangan lah, the planning of this particular course, EAS 458. Okay. So far no question, because I can see there's no question in the chat box. So that's all for the teaching plan. So please refer to this. If there is a change, if there are any changes, I will inform you. So at the moment, this is what we have agreed. Inshallah, the project will be given to you by next week. By next week. Okay. Go to the slide back. Okay. So I hope you are ready now. So how many of you now? 69. Okay, it should be 96. Tak apalah. Okay. For today's topic, which is introduction to pre-stressing, this topic is not very hard. There is no calculation, just introduction of what is pre-stressing, the principle behind that, and how to classify pre-stressing, and also methods of pre-stressing. So basically, those are the things that we are going to cover in this particular chapter. The full notes in e-learn. So I hope you read that one, because nanti later on there will be assignment for that. Okay, let's start the introduction. So the main objective of this chapter to demonstrate the basic concepts in pre-stressing and the learning outcomes. I hope by end of this lecture you can explain the principles of pre-stressing, describe the pre-stressing methods, and also summarize the pre-stressing classification. So basically, the outlines of today's presentation or lecture will be three sections. I will talk about the principle of pre-stressing, and then methods of pre-stressing, and classification of pre-stressing. Actually, you can read this by yourself, easy to understand. But so I just highlight a few things only. This is a QR code for attendance. So we start with the principle of pre-stressing. So I hope by end of this lecture you can answer these two questions. So what is pre-stressing and what is pre-stress concrete? So before we try to answer this, let's go to the origin of this pre-stressing pre-stress concrete, which is concrete. It comes from the concrete. So what is concrete? So now you're already in the final year. I hope by now you can answer. When people ask you what is concrete, so you can jawab. You boleh jawab. I hope that. So what is concrete? You can say that it is a building material. Building material made from what? Sorry. Okay, made from a mixture of what? Gravel, right? Sand, cement, and water. Either you can spread it or you can pour into the mold to form a hardened mass. So that's a concrete. So as you know, concrete ni the weakness is what? The weakness is tensile. Weak in tension, but concrete is strong in compression. If you consider any simple beam, like here, simple beam here. So the bottom part will be the tensile and the upper part will be the compressive. So basically, if you consider only a plain concrete, and when that particular concrete subjected to any load, in this case point load for example, in a very small amount of load, this particular concrete will be easily deflect, and also finally it will collapse easily, abruptly. So to tackle this particular problem, so the engineers have suggested two ways: either reinforcement or we perform pre-stressing. So that's how these two things come to tackle the problem of tensile, because we know the weakness of the concrete is cannot resist tension. There is no tension, we ignore that tension, right? So we try to overcome that by considering reinforcement or pre-stressing. So in this particular case, if you consider this kind of beam, of course you know that the problem will be at the bottom part. It will crack easily, deflect, and also it will crack. So we look at the reinforcement first. How come this thing? I don't know. Okay. Okay, reinforced concrete. What is reinforced concrete? Just now is concrete. Now we have reinforced concrete. Reinforced concrete is a concrete in which we have embed the steel bar inside that particular concrete. But to embed that particular steel bar, you cannot simply put that one in the concrete, right? So since we want to tackle the problem of tension, so usually we will put or we will embed that particular steel bar in the area of tensile. In the area of tensile. So that's how we try to overcome the problem of the concrete by introducing a steel bar at the area of the tensile fiber. Yeah? So that's, we have reinforced concrete. But still in this particular reinforced concrete, crack can happen. Yeah, we cannot apa ni eliminate that particular crack. Crack still can happen, but we can limit that cracking. So since RC is easily cracked, the problem will be corrosion lah. The beam, for this particular case, the beam, the RC beam, will facing the problem of corrosion because the existence of this particular cracking. So to avoid or to improve or to overcome RC problem, that's come this prestressed concrete. That's how this particular prestressed concrete was developed or was invented during the previous years lah, so 1830s or 20s last time. So to increase the concrete strength further, the compressive stress is induced into the concrete member before it begins its working life. That's pre-stressed concrete. Different with the RC. RC, you embed that particular RC. The reinforcement or steel bar inside that particular concrete. But for pre-stressed concrete, we are actually introducing compressive stress inside that particular concrete member before that particular structure or concrete member used for service period lah, before that. So during the construction, we introduce this particular compressive stress inside this particular concrete. So where to position this compressive stress? Of course, in the area of tensile, which is the bottom part of the concrete. The bottom part of the concrete itself. Sama lah, it's quite similar to what RC, the concept. But instead of we put we put just embed the steel. This time that particular steel, we try to pull that one, become a tension, and then we induce compressive stress in this particular concrete. So the initial load or pre-stress force is applied to enable the structure to counteract the stresses arising during its service period. So the reason we induce or we introduce the initial compressive stress inside this particular concrete in order for this particular concrete counteract the stresses developed by the service load. Life load lah, of course, during the service period. So that's pre-stressed concrete. We are talking about how tackle the problems of the tensile in this particular concrete. So I hope at this stage you can differentiate between RC and PSC. RC, you just embed the steel. However, in pre-stressed concrete, yes, we embed the steel, but that particular steel is we pre-tension or we post-tension first in order for us to introduce a pre-stressing force inside the concrete before that particular concrete begins its working life. So at this stage, what is pre-stressing and what is pre-stressed concrete? So we can say that pre-stressing is the application of a force to the structure. Application of the force to the structure other than the applied loads. Other than the applied loads. Applied loads ni come from where? From the service lah. From the service loads during its working life, the structure working life. For the purpose of introducing the internal stresses, of course, these internal stresses should be suitable magnitude and distribution. You have to design that, which assists the performance of the structure. That's pre-stressing. Pre-stressing ni method lah. It's a process of introducing internal stresses, or that particular internal stresses we call it pre-stressing force. And of course, that pre-stressing force should be certain magnitude and certain distribution. You tak boleh simply you just introduce that particular stresses inside the concrete. And what is pre-stressed concrete? So we can say that pre-stressed concrete is a modified form of RC, in which internal stresses of a suitable magnitude and distribution are introduced so that the stresses resulting from the external loads are counteracted to a desired degree. External loads, understand, and external load is from service load lah, live loads, of course lah, live load je lah yang ada, or maybe dead load lah. Okay, so that's pre-stressing and pre-stressed concrete. Sorry, I heard bukan voices, noise. I think some of you tak tutup mic. I'm not sure siapa. Please check. There is a mic on. Okay. So I move to the next one. So what is the objective of pre-stressing? Of course, you want to eliminate the cracking lah. That's the main reason. Sebab that's the main problem of concrete. It's to eliminate the cracking, and in other words, to eliminate the tensile lah. At least up to the service load levels. Control or eliminate deflection at some specific load level. Allow the use of high strength steel and concrete. Kalau if you design for RC, if you use a high strength steel, there is no advantage pun. There's no advantage. So this is how we are going to use that high strength steel lah. Basically, we use in pre-stressing. Net results of pre-stressing, improve performance of concrete. Okay. Saya rasa ada tak tutup mic lah. Lam Wen Xiang, your mic is on. Can you off? Sorry. Okay, net result number 1 tadi, improve performance of concrete when we compare dengan RC. And then extended range of application of structural concrete, which is by using pre-stressed concrete, we can get a longer span lah. Selalunya pre-stress ni digunakan is used in bridge design or highway, elevated highway whatsoever. So it can go up to certain spans, certain meters of span compared to the RC. And of course, by using pre-stressing, innovative forms of structure. Dia ada bentuk macam-macam. If you can see from the internet, you type and you can see that pre-stress, there are box girder, innovative forms kan. There are U-shape, T-shape, and so on, so on. So that's the net results of pre-stressing. So these are some of the pictures I got it from the internet. On the application of pre-stressing. So most of the structure is a bridge. Bridge in Malaysia use pre-stressed concrete. So this is for water tank, which is a high pressure. So it's good to use pre-stressed concrete. And this is the span pile. Span pile also using pre-stressing concept. So if you want to know more about this, you can read in the internet lah. I suggest you. There's so many. Okay, the basic theory of pre-stressing. Just now I already told you on the what is pre-stressing. Pre-stressing ni, you just bear in mind, pre-stressing is you introduce certain amount of loads ataupun stresses inside that particular concrete. We introduce some amount of stresses. But how to calculate that ataupun how to show how to look at that particular concept in mathematical way. So let's say you consider one simply supported beam loaded with UDL 10 kilonewton per meter, and the span is 8 meter. So let's say you have this kind of beam, 8 meter, loaded with uniformly distributed load, 10 kilonewton per meter. And let's say you have this cross section of this beam is 200 by 500 millimeter. The cross section of this particular beam. So what will be the stresses of this particular beam. So I already calculated for you here, 9.6 for the top and 9.6 for the bottom. Equal value because the cross section is rectangular, right? Do you know how to calculate 9.6? How to get that 9.6? I hope you know how to get that 9.6. This is in RC. You dah belajar. You have learned this. So what are the formula you use to determine stress distribution in the beam? I'm talking about at the midspan, at the midspan, kat tengah-tengah tu. Of course lah, when we design for the highest value of bending moment kan. So we consider this 9.6 yang saya kira ni is at the midspan. So the formula you use is M over Z, right? M over Z. Kejap. Stress M over Z. So M over Z. So that's how you get this 9.6 and negative 9.6. Negative is referring to the tensile, positive referring to the compressive. Compressive force or compressive stresses and tensile stress. So in pre-stressing, what we want to do is we want to eliminate this 9.6 Newton per square millimeter. We don't want this. That's the purpose of pre-stressing. Because tensile is the weakness. We don't want that. It will make that particular structure crack. So how to eliminate that? So we need to introduce certain amount of pre-stressing force that can eliminate that 9.6 Newton per square millimeter. So that's how pre-stressing work. So how to do that? Of course, usually we introduce, this is pre-stressing. Of course, we will introduce a certain amount of force here. For example here, and you need to calculate this P. What will be the value of this P in order for us to eliminate that 9.6 Newton per square millimeter. So that's how pre-stressing is working. We already know stresses due to bending, representing by this shape. And for P here, the introduction of the new force here, the distribution of the stresses will be like this, which is to determine the stress, it will we just use P over A. P is the value of the force and A is the cross section of the beam. So we want to make sure that the bottom part here, the final results will be zero stress. Or maybe you want to have positive, certain very positive numbers also can, as long as not in tension. So the bottom stress here, FB here, B is bottom and T is the top. So the total stresses at the bottom part should be 0 or maybe more than 0. Also can, acceptable. But still we need to limit that value. That one in chapter 2 later on. So how to do that? You need to calculate what is the value of P. So how to calculate the value of P? Very simple. You just use a mathematical operation. So we have this P over A, the stresses due to this new force, plus with the stresses developed due to the UDL just now, which is M over Z, and equate that one equal to 0. So from here, you can obtain the P value, which is in this particular case, or in this particular example, it will give us the P value should be 960 kilonewton in order for us to eliminate the tensile in the bottom part. So once you confirm the value of P, next you can calculate what will be the stresses at the top here. So just P over A, 960 over the cross section, plus with the 9.6 just now. So the total of the stresses at the top one will be 19.2 Newton per square millimeter. So this is how pre-stressing work in the pre-stressing design. And of course, in chapter 2 later on, usually we can introduce this P value ataupun this new force here, starting from this neutral axis of the beam until to the soffit of the beam. So you can, maybe you want to put P here for a certain eccentricity. You consider certain eccentricity here. This is called E, eccentricity. Introduce P. Of course, you need to design. This one later in chapter 2. So in this particular topic, I just want to introduce to you how this pre-stressing calculated, the basic theory of this pre-stressing. So this is how the principle of pre-stressing in pre-stressed concrete design. Okay, this is what I told you just now about the introduction of the E value here. Once we have this certain eccentricity, we introduce P not at the neutral axis, there will be another stress distribution that we need to consider, because there will be moment developed here because of this eccentricity, like this. Once you introduce a P, a new force, at a certain eccentricity from this neutral axis, moment will be developed. So your stress distribution will be covered by 3 components, not 2. Just now 2, right? We have 1, 2. We have to add another component here, something like this lah, due to bending moment. Bending moment of the eccentricity because of this eccentricity. So that's one. So later in chapter 2, we look at that in details. Today you just understand the basic concept in pre-stressing. Okay. I have this question actually. I hope we can go through, but I'm not going to solve this one today because I think better we solve it in chapter 2 later on. Okay. So advantages of this pre-stressing. Of course, we hope the section or the beam, for example, remains uncracked. That's what we want under service loads. Once we can eliminate that crack, we can reduce corrosion. When we reduce the corrosion, we can increase the durability. Itu konsep asas, basic concept in when you're dealing with the concrete material. We want to avoid corrosion. We need to avoid crack. Once you can avoid corrosion, you can avoid crack, definitely you can increase the durability of the concrete. Another advantage, full section is utilized, higher moment of inertia, so it will give you higher stiffness, and of course less deformation. So when less deformation, service will be improved. Increase in shear capacity, suitable for use in pressure vessels, liquid retaining structure, improve performance under dynamic and fatigue loading. Some of the advantages. And high span to depth ratio, as you can see in the table here, for RC span to depth ratio, it can go up to 28.1, but for PSC it can go up to 45. Company quite good lah when you use PSC. And suitable for precast construction because of rapid construction, better quality control, reduced maintenance, suitable for repetitive construction, multiple use of formwork, and availability of standard shapes. So that's what is advantage. And this is some limitation. I don't want to say this is disadvantage, but this is limitation at the moment lah. So pre-stressing, of course, needs skill technology, and it use high strength material, which is quite costly. Additional cost for the equipment, and also during the casting of that PSC, quality control is very important. So this is the limitation, not disadvantage. Yeah? Okay. Okay, next, what is this? Okay, what are the concrete used for PSC and also steel used for the PSC in order to casting the PSC? The main factors for concrete use in PSC, we just use OPC yang biasa saja. But the strength usually more than 50 Newton per square millimeter. High early strength is required to enable quicker application of pre-stress. Larger elastic modulus is needed, and a mix that reduce creep of the concrete to minimize losses of the pre-stress. Any QC very important lah, to check this one. And the steel used for PSC, usually the strength between stated over the in the slide here, from 1,500 to 1,800. Different forms of steel may take. We can use wires, strands, tendon, or bar. Okay, this one I'll explain later in the next slide. Okay, finish for the principle of pre-stressing. Do you have any question at the moment so far? Okay, there is no question in the chat box, so I proceed. Okay, method of pre-stressing. When we're talking about pre-stressing, there are two methods: either pre-tensioning or post-tensioning. So there are two ways. So before we go to that methods, let's see forms of pre-stressing steel. There are basic types of high-strength steel listed here. As you can see in the slide: cold drawn stress relief round wire, stress relief strand, and high strength alloy steel bars. So what is tendon? I believe you have heard these words frequently. Tendon, kalau this is from the book lah, from the book. But if you're talking to the engineers, when we say tendon, what they are referring is to the post tension. There are different what we call it, different from the books. But books define tendon as a wire or strand or cable or bar that is intended to be either pre-tension or post-tension. So when we're talking about tendon, it can be a wire or a group of wire, a strand or a group of strands, a cable or a group of cable, or bar. However, when you're talking about engineer outside, when we're talking about tendon, they will referring to the post-tension, the second method of pre-stressing. But that one is okay, just information for you. So what is wire? Wire usually use cold drawn stress relief round wire. The diameter between 2.5 to 12.5 millimeters. There are two types of wires for this particular case, either plain wire or indented wire. Indented wire is better than plain wire lah, because it can improve the bond between the concrete and also the steel. So this is example of plain wire. Nothing here at the surface of the wire. This is indented wire. There is some corak-corak here at the surface. Okay, that's wire. And what is strands? Strands, when a few wires are spun together. Spun together ni means twisted together in a helical form to form a pre-stressing strand. So instead of using one wire or two wires, now they use a few wires. They spun together or twist together to become one strand. So of course there are standard for that. You can either putting two wire together, or three wires together, or 7 wire together, and 19 wire together. This is standard. So kalau if you want to buy this particular strand, they come with the standard size, standard amount of wire lah for the strand. Okay, diagrammatically you can look at here. This I took from the internet lah. So this is 2 wires. You see how they spun together? Something like a twist. And the 2 wires are twist together to become one strand. And if you have 3 wires, this is 7 wires. 6 wires spun together towards the center of 1 wire here. And this is 19 wires. So this is standard. available in the market. Okay, this is strands. So what is tendon? Tendon, a group of strands. Okay, just now strands, a group of wire. Now a group of strand, when you combine, maybe you combine a few strands, 2 wire strand or 7 wire strand with a few groups of 7 wire strand, you spun together or you group together, sorry, not spun together, you group together, that one we call it as tendon. Usually tendon we put in a duct. This is a duct, the circle here, put inside the duct. The tendon put inside the duct, or a group of strands. A group of strands, we call it tendon. Put inside a duct. This is called tendon, usually in post tension. Cables, what is cables? A group of tendons. A group of tendons, you spun together, that one we call it cables. Usually cable used in post tension concrete. And also we have bar. This is not so common but available. Bar, a tendon made up of a single steel bar. Not common lah, tapi but available. So in Malaysia, example of pre-stressing contractors, the most popular one lah. We have 3: Fresinet, VSL, and also BBR. So if you later working in the construction, these 3 names not avoidable. Tak boleh dipisah, tak boleh dielakkan. These 3 names, they are very common in the market. Okay, that's forms of pre-stressing steel. So as I mentioned earlier, there are 2 methods of pre-stressing, either pre-tension or post-tension. So what is pre-tension and what is post-tension? I hope you can see the difference later on. I read through this bullet first. So the high strength steel tendons are pulled pre-tension between 2 end abutments prior to the casting of concrete. So what you understand by this is, before you pour the concrete in the mold, we need to pull the tendon first, or the steel strand, for example, or wire first. We pull that one, and that particular tendon is in pre-tension. After that, the abutments are fixed at the ends of pre-stressing bed. Abutment is used to hold the strands or to hold the tendons. And then we pour concrete. Once the concrete attains the desired strength of pre-stressing, the tendons are cut loose from the abutments. After we pour concrete, we wait for certain days until that particular concrete attains desired strength, not full strength of the concrete, 60% only from the concrete. Let's say you design for 50, maybe 60% for the 50, 30, for example. Once the concrete attains 30 design strength, then we cut the tendon that we have pre-tension at the early stage of this process. So the pre-stress is transferred to the concrete from the tendons due to the bond between them. During the transfer of pre-stress, the member undergoes elastic shortening. This is some of the losses that you need to consider when you design pre-stress, elastic shortening. If the tendons are located eccentrically, the member is likely to bend and deflect. This is common. Kalau let's say originally your beam like this, sorry lah, this thing I don't know why dia keluar. But okay, after you apply this, okay, this is strand ataupun wire. Okay, you have this P value here, P value, force. So your concrete now, it will bend upward like this. Okay, my picture is not beautiful. Kejap, saya cari. I think I have in the slide. Where is it? Here. After the wire have been cut loose from the abutment, it become like this. And then later on, once this particular beam undergoes its service life, we expect this particular beam will become straight like this lah, not deflect downward. Dia tak deflect downwards. We want to avoid that. That's the concept in prestressed concrete. Yeah. Of course lah, you cannot avoid that deflection. But then that particular deflection reduce banyak lah compared to the RC. Yeah. Okay, I go back to the slide. Wait. Where is it? Okay. So this is the process of pre-tension. So what we can conclude, we tension the wire first. Wire ke, strand ke, or bar ke, or tendons ke, or cable. You pre-tension that particular steel first, and then pour concrete, wait certain days or certain times until desired strength. Then we cut loose the tendons, and then that particular stresses will induce or transfer into the concrete. Yeah? Okay, this is pre-tension. So these are some diagram. I got it from one of the. If you refer the notes, I put the website of this. Where did I get this particular diagram? You have this bed here. This is mold. So this is tendons. Yeah, tendons. What is tendon? A group of strands. Yeah? And we have abutment to hold that particular tendon, and then we have jack. What is the purpose of jack? Jack is to pretension the wire, supply the energy for pull that particular tendon. Pull first, and then after that pour concrete. Once concrete attains certain strength, then we release that particular tendon, so it become deflect like this. This is stages in pretensioning. Okay, so this is another diagram about this pretension, the real diagram. This is this illustration. So this is the real diagram. So this is jack that will pulling the tendon. So this is the abutment that hold the tendon. That hold the tendon. Okay, devices used in pretension. So there are a few here. You can read by yourself here. We have bed. We have an abutment, mold, jack, anchoring device. Anchoring device quite similar to the abutment lah, function dia. Because like this, abutment to hold the strand, and then after you cut loose, this anchor will lock that particular tendon in order that particular tendon maintain in tension or something like that. Harping device is related to the curve. You put some harping device so that this one become curve like this. Put here. So for example, okay, this is if you look at this diagram, this is a production of the single prestressed concrete. But in kilang, in factory, this is not the case lah. Usually, there is an extension of this particular system. We call it Hoyer system. In other words, a few series of mold installed, and we can produce a lot of prestressed concrete at one time. So usually, this is what factory will use. This part. Hoyer system, or we call it long line method, instead of single. Okay, it can be happen. This is jack. We have three types. In terms of when we're talking about pretension, how to pull that particular strand or tendons, either using hydraulic, mechanical, or electrical. So this is jack using hydraulic jack. To pull the tendon. This is an example diagram showing the anchoring device to lock that particular tendon, so that it always maintain in tension after you cut loose from the abutment. Okay, what is the advantage or disadvantage of pre-tension? So pre-tension is suitable for precast members produced in bulk. Pre-tensioning large anchoring devices is not present, tak wujud, tak ada. So there are limitation lah. Sorry. Kenapa saya letak kat sini? I take note on this. Nanti saya check balik. Sorry. Okay, disadvantages. Pre-stressing bed is required for the pre-tensioning operation. You need these things. There is a waiting period in the pre-stressing bed before the concrete attains sufficient strength, and there should be a good bond between concrete and steel over the transmission length. Yang ni Prof. Bud will tackle this topic about this thing. About this thing. Okay. Next is post-tension, the second types of methods of pre-stressing. What is different dengan pre-tension just now? Okay, I read this first. So the ducts for the tendons or strands are placed along with the reinforcement before the casting of concrete. In pre-tension, we don't have this duct, but in post-tension, we need a duct to put the tendon later on. Okay. So the tendons are placed in the ducts after the casting of concrete. The duct prevents contact between concrete and the tendons during tensioning operation. Okay, different with the pre-tension. We have this duct. We install this duct together with other reinforcement of the concrete of the beam, for example, the beam. And then we pour concrete. In the meantime, we wait for the concrete to attain certain strength. We place the tendon inside that particular duct. So the difference with the pre-tension. Pre-tension, you pull the strand first, and then you pour the concrete, and then you wait for certain time, and then we lose the strand. In this particular case, the other way around. We install the duct first. The duct ni kosong lah, empty. There is no tendon inside that. Together with the other reinforcement, and then we pour concrete. In the meantime, we wait for the concrete to harden. We placing the tendon. We put the tendon inside that particular duct. Once the concrete attain certain amount or certain design strength, then we pull the strand or the tendon. That's how in post tension. All right. Post tension, we wait for the we tension first the strand. After concrete harden, then we loose. But in this post tension, no, we don't pull the strand first. No, we pour the concrete. In the meantime, waiting for the concrete to harden, we put the tendon inside that duct. Once the concrete attains certain design strength, we pull the strand. Okay, that's in post tension. So in post tension, we can call it bonded post tension or unbonded post tension. Bonded post tension means the duct just now, the duct that place the tendon, you can grout that one. If you grout that particular duct, we call it bonded post tension. If you put that particular duct remain empty like that, there are space, then that one we call it unbonded post tension. So there are two ways lah, either bonded post tension or unbonded post tension. Another things that make different, okay, this is just the stages. Casting the concrete, placing the tendons, placement of the anchorage block and jack, applying tension to the tendon, setting the wedges. Wedges ni triangular shape we put at the end of the tendon to hold that particular tendon, and then cutting the tendon. So these are the stages in post tension. And at the end of the tendon in post tension, it's quite different with the pre tension. There are two ways: either we make it dead end or we make it live end. Dead end like this, meaning to say that this is the end of the post tension of the tendon. If here is then dead end, the other end will be live end. Live end is where the jacking will pull the tendon. The other end, which is we call it live end, that's where the jack will tension that particular strand. Okay, these are some devices used in post-tensioning. Quite similar to pre-tension jugalah, what we need. Okay, I just show you. Coupler is used if that particular structure connected to another structure. For example, beam will be connected to the column, for example. So we need this coupler. Okay, this is just for your knowledge lah. This is a machine for grouting. Okay, the last part of this chapter 1 is about classification of prestressing. There are many ways to classify prestressed concrete or prestressing. So I listed here a few. Number 1, classify according to the source of prestressing force. The source of prestressing force, kalau just now in pretension, is from the jack. From the jack. That one is a common practice lah. There are 2 other ways. Jack usually hydraulic, mechanical also can be used, and electrical also can be used. So this we can classify prestressing according to the source of prestressing force. Maybe we call it mechanical prestressing, hydraulic prestressing, or electrical prestressing. That's one way. Another way is external or internal prestressing. External and internal prestressing is classification based on the location of the prestressing tendons. What does it mean by external and internal prestressing? Ni adalah the location of the tendon itself. The location of the tendon. If external means when the prestressing is achieved by tendons located outside the structure, outside the concrete member. The best example that I can give you is box girder. Box girder kan bentuk dia, the form is something like this. Sorry. Oh my god. Okay. So the tendon will be somewhere here, maybe outside the beam. This is of course lah. This is your beam kan. Macam ni, something like this. Okay. So dia in the hollow section here, in the hollow space here, your tendon. So this is external prestressing. Internal prestressing inside lah, located inside the concrete, something like this. For example, this is inside. So we call it internal prestressing. Kalau inside this hollow space here, we call it external prestressing. Usually this one for post-tension. Post-tension, not pre-tension. Post-tension. Okay. That's another way to classify the prestressing. Another way is this is common jugalah, which is based on method of prestressing, either pre-tension or post-tensioning. This one already explained just now. Another way to classify the prestressing is either linear or circular prestressing. This is depend on the shape of the structure, the shape of the structure that being prestressed. I give you one example here: circularly prestressed containment structure. And next classification of prestressing, either full, limited, or partial prestressing based on amount of prestressing force. And the last one is based on the direction of the prestressing. So it can be uniaxial, biaxial, or multi-axial prestressing. If you want to know further on this, you can check out in the internet, books, or whatsoever lah. There are so many explanation on this. Okay, so finish for chapter 1. I'm not going to explain on chapter 2 today. So, okay, first, do you have any question? Ada soalan tak? Okay, let me see. Okay, jap. Okay, yes, correct. Lam Wen Xiang. If you if you can read the questions, quite long question when siang, so I don't have to read, but please read it by yourself. Yes, correct. When you do pre-stressing, when you do design later on, we have to limit the stresses that we are going to introduce into the concrete. That's why we will have this stress limit, and usually we try to limit that one until up to the elastic limit. Elastic limit. Not, saya rasa, I think so far I I haven't came across they consider more than that. Yeah, up to the yield strength. No, tak pernah. So because when you design pre-stressed concrete, uh, there are certain things that we need to take into consideration. Number one is itulah, we design only in the range of elastic limit. Yeah? So good question from Wen Xiang. Okay. Chapter 2 we will see on this again. Yeah. Regarding this particular question. Okay. Any more question? Okay. Tak ada eh. So if there is no question, okay, for this chapter 1 there will be assignment covered under assignment. Uh, my assignment this time is I will go for multiple choice question, MCQ question. So everything online in eLearn. So but later on lah, not today or not next week, because another topic should be covered under assignment is losses. The third topic. Yeah. So after that, then we have that particular assignment. Yeah. So please read the notes that I give to you in the PDF form in the eLearn. Okay, any more question tak? Ada lagi soalan? Okay, so far tak ada. So I think we end here. Please read this thing. Please stay safe. You all dah habis quarantine kan, so dah boleh keluar lah. Tapi but still please jaga SOP semualah whatsoever. So this is attendance for those who still not ni lagi the attendance. So I end here. Thank you. See you next week. Physically. Okay, bye.